So with no signal connected to the RF input of the analyzer, let's press the green preset button to put the instrument back to its factory default state. You can see here the factory default for the N9342C is a center frequency of 3.5 GHz and a span of 7 gigs, so we're sweeping the entire frequency range here. You can see here the reference level, that's the top line of the graticule, is 0 dBm. We've got a log scale on the y-axis of 10 dB per division. There's 20 dB of attenuation. The resolution bandwidth is 3 MHz and the video bandwidth is 3 MHz. So let's select a center frequency of, say, 2.4 GHz. And let's zoom in a bit. So I'll press the span button and select a span of, say, 100 kHz. Now, a couple of things happen when we do that. First of all, the span changes, of course, so we're now only sweeping over a 100 kHz range, but you'll notice that the analyzer also selects a narrower resolution bandwidth, in this case 1 kHz, and the sweep speed, of course, has increased as well. We're now sweeping at 5 milliseconds. The most significant thing you'll notice, though, is that the noise floor of the trace here has reduced significantly. If you're not familiar with Boltzmann's law and why narrowing the resolution bandwidth also has the effect of reducing the noise floor, refer to application note 150, which you can download from Agilent's website. So if I press the marker button, you can see that the noise floor is now around minus 90 or so dBm. Now there's a couple of things we can do again to improve that sensitivity still further. The first thing I'm going to do is press the amplitude button and adjust the reference level to bring the trace further up onto the screen. I'm then going to set the attenuation to 0 dB. You'll see we've gained about another 10 dB of sensitivity there. And if I reduce the resolution bandwidth still further by pressing the bandwidth button and then resolution bandwidth, set it to manual, and we'll reduce that to its narrowest, which is 10 Hz. Now the sweep time is going to go up to about 8 seconds, so it'll take longer to sweep the trace. But you can now see the marker, we've got an amplitude value of about minus 133, minus 132 dBm. And finally, if you've got the internal preamplifier option on your analyzer, I can press the amplitude button and turn preamplifier on. And I'm going to need to bring the trace back up onto the screen again, so I'll press reference level and we'll just bring that up onto the screen here. And you'll see we've got a sensitivity now of almost minus 150 dBm. Now, because this instrument is so sensitive, we may actually be picking up stray signals from around the room through the open type N input connector on the top here. So let's terminate that with a 50 ohm load. I'll press span and zoom in a bit more. And I'll press trace and more, and let's turn on averaging. And you'll now see the really amazing sensitivity of Agilent's handheld spectrum analyzers. You can see here the marker is now reading minus 156, minus 157 dBm. If you'd like further information on these products, including demonstration guides, operating manuals, or application notes, please visit the website shown below.